This is our group presentation on prime numbers. So what is a prime number? A prime number, as most people know, is any number that is divisible by 1 and itself. So for example, 3 has factors of only 1 and 3, whereas 4 has factors 1, 2 and 4, so it's not a prime number. As you can see on the screen, this is all the prime numbers lower than 100, but this list will carry on forever as there are an infinite amount.
A lot of examples of where prime numbers are used is the RSA algorithm. It's made by these three gentlemen here. And the main premise of it is where a message is kept safe through a lockpad, for which only the receiver has the key for. So how does it work? Well, it's all based around these two equations, where n is the product of two very large prime numbers, e is the encryption number, d is the decryption number, c is the encrypted message that's getting sent, and n is the decrypted message. So why is it so safe and used so widely? Well, it's all based around the idea that it is very difficult to prime factorise a massive number. Modern numbers used by, for example, banks or social media providers is they use numbers that are well over 600 digits long, meaning that their product is upwards of 2 to the power of 2048 digits long, which is ridiculous. So, as seen from this graph, the larger a number, the larger the two numbers get, the longer and longer it takes to factorise. It seems as a 400-digit number, it would take upwards of 700 years to prime factorise it. That's pretty much why it works.
In the field of engineering, gears are designed in such a way to provide mechanical advantage by having a co-prime number of teeth with other gears that they interact with. So for example, if one of these gears had 7 teeth and the other had 11, because those two numbers are co-prime, they would not interact with each other on a regular basis. So why is this relevant? This technique of design is used so that the distribution of wear and tear across the teeth is evenly distributed, and so this increases the gear's efficiency and the longevity of how long it can be used.
Numbers play more of a role in the field of cryptography and mathematical research more than other fields, and we know that programmers involved that help us to keep our privacy safe will have to do with a lot of prime numbers. And from the previous slides, we know that programs that are very secure can involve a long prime numbers, and our currently largest prime is 23 million digits long. So who knows how long the prime numbers involved in our program can be. So now we can see how programmers got paid so much just to do that. But mathematicians, on the other side, aren't so keen on finding those large prime numbers, but more on finding how they behave and finding the patterns so that they can contribute this knowledge to number theory so that we know more about numbers and we can apply that knowledge in our field as well.
Thanks for watching!